Welcome to Azal Engineering YouTube channel. In this video, I will show you how to decide or calculate spacing of stirrup on beam, that may be maximum and minimum spacing. Watch this video up to the end since the last point is a game changer. Subscribe my channel and share this video to structural engineers, site supervisors, contractors, civil engineering instructors and students. Let's dive into the video. First of all, I would like to tell you what is spacing mean, and in the last, what is a stirrup mean. A spacing is nothing but it is the gap between stirrups, and stirrups are a reinforcement that is provided for shear force. After this, we will see four main points, and at the last, I will add you one important bonus point. The first point that we have to see is a spacing of stirrup is maximum around the supports, and it is a minimum at the mid span. This is because shear is maximum around the support and it becomes zero at the mid span. For example, let's take two columns with a length L between them, and the beam at the top of these two columns. So the spacing of a stirrup around these two columns is maximum, and at the mid span it becomes far apart and it becomes minimum. This is because the shear is zero around the mid span and it becomes maximum around the supports. The second main point is that spacing of stirrup also maximum around the junctions of the beam. And the third point is that maximum spacing of stirrup must not be greater than 0.4 times D. This is in case of Aero code, and it becomes 0.75 times D in case of IS or that of Indian standard, where D is the effective depth of the beam, and the minimum spacing of stirrup for beam is 200 millimeter in case of Aero code. So you can use one of these codes. In case of Ethiopia, it's better to use Aero code because Ethiopian building code of standard is the same as that of Aero code. So the last point, that is the fourth point that we have seen, is spacing of stirrup depends on grade of concrete and percentage of reinforcement. If grade of concrete is good and if there is a maximum percentage or number of reinforcement, our spacing become maximum. So spacing of a stirrup depends on the grades of concrete that we have to use and percentage of reinforcement. I want to tell you one important bonus point, which is total number of stirrup is equals to total lengths of beam divided by the provided spacing plus 1. So as an example, let's take a 6 meter span beam. So let's take a 6 meter span beam. Total length of beam is equals to 6 meter. So if you divided this 6 meter to 3, that is total length over 3, we have to get 2 meter, which is 2000 millimeter. So the maximum spacing of spacing of stirrup for this beam around the support takes 4 meter, that is 2 meter in this side and 2 meter in the other side, and the middle part is 2 meters. So if you take the left side of spacing of stirrup around the support, so that is length is equals to 2 meter, which is 2000 millimeters. So total number of stirrup is equals to 2000 millimeter divided by 2000 the spacing, which is D over 4, or 0.4 times D, which is 0.4 times 4, which is 100. So 2000 divided by 100, which is 20. So total number of reinforcement is 20 around the left sides of the support. So you can calculate total number of reinforcement like this and add the total length. These were the most important point regarding to spacing of stirrup on beam. I hope this video is helpful for you. Please like this video and subscribe my YouTube channel to get new updated video. See you in the next video. Thank you.